In this part of the video, I'm going to talk about single displacement reactions. Now, in the previous part of this, the presentations for this chapter, they've all been labeled with the word replacement. Okay, either one is fine. So if you see replacement or displacement, know they're talking about the same type of reaction here. And if I say single replacement or single displacement, just know they're the same. There's not a difference between those two. So let's look at what it is. So we have a single element, one element. And up here, they're just referring to it in the notes as A. Now, how will I know, looking at a chemical formula, that it is an element? Okay, so think back. This is like in chapter 3. So elements can only consist of one type of atom. So if we're looking at a chemical equation and we see only one type of atom, that would be an element. So in this first example here, zinc by itself is an element on the reactant side, and hydrogen by itself here is on the product side. And both of those are elements. Now hydrogen has two of them. It's diatomic. However, it's still considered an elemental form because it's only hydrogen. Now, for me, this is a good place to again remind you of the 7 diatomic elements. So these elements, when they're by themselves, want to be in groups of 2. And we have hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So when we are writing chemical equations and hydrogen is one of the products, we won't just write H. We will write H2 because it's one of the 7 diatomics. Okay, so back up to the top. So here we have, we have one element. So here's my first element, zinc, all by itself. And it's reacting with a compound. So right here is the compound for this example, HCl. And what it's going to do is replace one of those elements and giving a new element and a new compound. So zinc, since it's a metal, will always interact with the element that's written first. Because if you think about ionic compounds, the cations, which are the metals, are written first. Now you may say, but hydrogen's not a metal. But hydrogen is a unique element in that sometimes it behaves like a metal, like when you write it first, and it also can behave like a halogen, like a non-metal. But if it's written first, it can act like a metal in terms of how it's reacting, not in terms of its properties, but how it's reacting. So what happens is zinc is going to come in and kick out or displace hydrogen. So now hydrogen, if you look over here, is all by itself. And zinc is going to take its place and get together with chlorine. Now, if you look at zinc with chlorine, you'll notice they didn't just take one zinc and write Cl, ZnCl. No, for the new products, you have to use charges to figure out their formulas. And I'll be specific here in just a minute. Let me write this. So when zinc displaces it, the reason they're all doing this is transferring electrons. And so zinc, its charge, it's a transition metal, but it only forms a 2+. And the chloride ion, which is a halogen, we learned through the octet rule that we would expect a 1-. So when these get together, it actually is going to take 2 chloride ions to balance the zinc. And so that's how we end up with the new formula. So in single displacement, and we're going to practice some, in single displacement, you have an element, in this case zinc, that's all by itself. And it will, if it's able, and we'll talk about that too, we'll be able to displace another element. So now on the new side, hydrogen is all by itself now. So there's always an element by itself. And the zinc gets together with the chlorine. Okay. Now remember that the states are written behind it, like S is for solid, AQ is aqueous, G is for gas, and AQ is for aqueous. I guess L would be for liquid. Now in this picture over here, that is zinc with hydrochloric acid, and you see it's kind of bubbling. Well, that is because of the production of the hydrogen gas. So it has the gas bubbling out, and the zinc is actually going to be dissolving into that solution. Now below it, we have another possibility. We still have an element all by itself. In this case, it's the nonmetal, which is specifically a halogen. And so halogens can only displace other halogens. And halogens are nonmetals. So remember, in ionic compounds, it's always going to be the metal, which is the cation, followed by the nonmetal, which is the anion. And so here, if we have a halogen, this chlorine will kick out the bromine right there. There's bromine. So now if we look on the product side, bromine is all by itself. So it displaced it. And then chlorine gets together with the potassium. Now again, you may say, oh, but you had Cl2 on the reactant side and just a K. Well, why isn't it Cl2K? Why is that wrong? Well, that is wrong for two reasons, but the first one that just makes me go, is that we put the nonmetal first. So we can't have that. Nonmetal can't be first. Then the second thing you might say, okay, well, why don't we write KCl2? Because I have Cl2 on the other side. But remember, we have to use the ions to get the new products. So this is not correct, because it's a K plus and a Cl minus, so it's a 1-to-1 ratio. Now, you might need to read over this slide and just kind of consider it, but what we're going to do now is talk about which elements will displace which ones. Like, they won't all displace everything. Sometimes it doesn't happen. And then we'll do several practice equations, so we'll kind of start from scratch, which is something, not totally scratch, almost scratch, something that I'm going to want you to do. So the first thing that's going to be important, and in class I will distribute one of these handouts, is we have an activity series. You don't have to memorize this. It's something that I'll give you. And this activity series is used to predict these single displacement reactions. So as we look on the table 8.2, the metals are all in a line, and at the top we have the highest activity. So potassium, it says increasing as we go up. So potassium would have the highest activity, and gold at the bottom would have the lowest. Now notice the halogens over here have their own chart. So halogens kick out halogens, so they get their own side, and metals kick out metals, so they get their own side. Notice hydrogen is here on the metal table. So here's what has to happen. A more reactive element will displace a less reactive. It really has to do with how much they want to get rid of their electrons. So what it tells me very simply is a metal or a halogen will only displace a metal or halogen that is below it on the chart. Okay, so specifically, let's look at these examples. Here is aluminum, which is the element all by itself. And here is aluminum on the chart. Okay, so that, I want to erase my hydrogen. So there's aluminum. And then I look, and the metal it would try to displace is copper. You can see over here they wrote the copper. So here's the copper, the metal it's going to try to kick out. Well, if I look here, copper is below aluminum. So aluminum is more reactive than copper. It's above it. And so aluminum will kick out copper. Okay, because aluminum is more reactive than copper. It's above it on the chart. So aluminum will kick out anything that is below it on the chart. Now, let's look at the other one. And I'm going to erase here. You can always rewind the video if you want to see that writing again. But I want to look here. So here's silver is by itself. And silver is going to try to kick out this metal copper. Remember, metals have to kick out metals. They can't kick out other things. So silver is right here, and copper is above it. So no reaction. Why? Because silver is less active than copper. And if we see up here, the more reactive can replace less reactive, but less reactive cannot replace more reactive. So silver by itself cannot kick out copper because it is less reactive. So that simply results in no reaction, or nothing would be happening. So let's take a look. I have, I think, 3 or 4 equations that we can try to practice. And then part of what your lab and homework is you doing this on your own. There's also if you look in Canvas under video lessons, there are other examples of these types of problems being solved. You can also look online. You know, there's lots of people that talk this stuff. Okay, so did I skip one? Let me see. So I only have one here. Okay, I will think I think I had a second one, and I will do that one too. I'll do one. I'll make my own, but we can do this one for right now. I must have overwritten it when I made the slides. All right, so here we have iron metal. So that is Fe is the symbol for iron, and it's a metal, so it's a solid. And I'm adding it to a solution, which if you ever see solution, it just means AQ, and it's magnesium chloride. Okay, so this is an ionic compound. So to get magnesium chloride, we have to know the charges. These are both representative elements, so we can use the periodic table. So it's going to take 1 magnesium and 2 chlorides, and it's a solution. So those are my reactants that they have given me. And now I want to predict to see if there's a reaction. So I have iron that's by itself, and iron would try to displace the other metal on the reactants, which is magnesium. So here's my chart. Here is iron, and look, magnesium's above it. So this can't have a reaction. So I would simply answer this one, no reaction. And I will put a because here so you can remember. So you only a more active metal that's by itself can displace a less active metal. So on that chart, if the one that's by itself, the one it's trying to displace has to be below it. Okay. So this would just simply be no reaction. We don't have to complete that. So let's look at this one. So now I have zinc metal. So there's the symbol for zinc, and it's a solid. And I'm adding it to copper 2 nitrate, which is a pretty blue solution. Okay, so I'm going to write down here copper 2, so that means it's a 2+. And with an ending with ATE, I know it's a polyatomic ion, and nitrate is NO3 negative. So when I put these together for copper, it's going to take 1 of them. And then since copper has a 2, it's going to take 2 nitrates. All right, so let's check our activity series and see if this will work. And I'm going to erase what I wrote before. Oh, let me go back so I can confirm. So here I have zinc that's by itself, and then it's going to displace copper. So zinc is here, and copper is here. So zinc, yes, zinc can displace copper because it is more active. So that's going to happen. All right, so here's the thing. Zinc is going to kick out copper. So here comes copper. And it's going to make an element. Remember, in single displacement, you have an element that's by itself, and then a metal or an element is displaced, and so now you have a new element on the product side. And then zinc is going to get together with nitrate. So if zinc comes over here and tries to kick out the copper, zinc wants to be where copper is. So you use the charges to predict the new products. So I know I'm going to have zinc now, and zinc is always a 2+. And I'm going to put it together with nitrate, which is an NO3 negative. And so that's going to take 1 zinc and 2 nitrates. Now, if you inspect this equation, you will see that it is balanced without doing anything. So we have 1 zinc on both sides, 1 copper on both sides, and 2 nitrate ions on both sides. Now there's a simple explanation why this one worked so easily in switching the partners, and that is because both the metals had the same charge. So when they were switching places, it literally was like they were just switching places because they have the same charge, so they can just replace one another. And so this right here, oops, this is AQ, sorry. This right here would be the completed answer for that problem. All right, so let me think of another one, and let's try another one. Okay, let's do one that has it reacting with an acid. So I'm going to have calcium, and I'm going to react it with hydrochloric acid. Now, this is single replacement. Again, there is a single element. Calcium is just an element. And so calcium is a metal, so it is going to try to displace, in this case, whatever's in the front, and it's hydrogen. Now, if we look back at our chart, let me erase this off. Calcium is up here, and hydrogen is down here. So calcium will definitely displace the hydrogen. Now on this chart, which was not on the previous one, I want to point out a little bit about hydrogen. So hydrogen can have several sources: cold water, steam, and acids. And so it can have these three, and not all of the more active elements can remove every hydrogen from all three. So like you see here, the top three can get hydrogen out of any of those. Then magnesium, aluminum, zinc, and iron, only steam and acids. And then as you get closer to the hydrogen, they can only remove it from acids. Now, I guess by pointing this out, I want you to think of, there's two things I want you to know. One is I want you to know that hydrogen can come from different sources. We have it from the water, either cold or steam, and then the acids. And then two, that even though some metals are more active than hydrogen, they may not be able to remove hydrogen from all of the different sources. Now, the thing I don't want you to worry about is on the exam, I'm not gonna try to make it where you have to use that part of the chart and figure it out. So I'm not gonna try to trick you with hydrogen. I will only give you ones that if the metal is above the hydrogen, it will be a situation where it can react. So I don't want you to get too caught up in all of that, but I just wanted to make you aware that hydrogen can come from not just acids, but from different types of water. In any case, calcium could take hydrogen out of any of it, cold water, acids, or steam. So let's look here. So it's going to kick out hydrogen. So yes, and so we get H2, excuse me, because hydrogen's one of the diatomics, and hydrogen is a gas. So we would expect to see some bubbling going on here. And then calcium is going to get together with chlorine. Now remember, you have to use the ions to get the new product. So calcium is a group 2A, it's a 2+, and the chloride ion is a halogen, so it's a 1-, so it's 1 calcium and 2 chloride ions, and this would be dissolving into the acid solution, so it's AQ. Now this equation is not balanced. Whoops, I didn't mean to erase my calcium. I was just trying to get the line. So let's balance it. Now remember, when you balance, do one element at a time. I'm going to start with my calcium. So there's 1 on the left and 1 on the right. That's good. Then I like to do my nonmetals before hydrogen, so I'm going to do my chlorine. There's 1 on the left and there are 2 on the right. So remember, what we're trying to figure out is how we make them equal. So I'd multiply this one by 2. And whatever you have to multiply it by, that is your coefficient. So I need a 2, and I have to put it in front of the hydrogen. I cannot put it in between or after the chlorine. So I put it there. And then I go, now I still have to balance my hydrogen. And so now, because I put the coefficient, I have 2 hydrogens on the reactant side and 2 on the product side. So in this equation, I balanced it by putting a 2 in front of the HCl. So what you need to practice here is you need to be able to identify these single displacement reactions, and then practice identifying, okay, if I have a metal, what is it going to kick out? Check your activity series. And then the other big mistake I have with people is they forget to use the charges to create the new product. So you've got to use the charges to create the new product. So there's our beginning introduction to single displacement reactions. You can watch this or watch a video lesson where I've done more examples. And then in lab, you're going to do 3 single displacement reactions, and you will yourself get practicing completing the equations and then balancing them. So it's going to take a little practice, but we can do it.